Hello everyone, welcome back to the AWS VPC creation playlist. So today we'll create a VPC from scratch once again. We'll be focusing on the topics we didn't cover in the previous video. Specifically, we'll focus on private subsets and how to enable internet access for the private instances, which we didn't cover in the previous video. Prior to getting started, a big thank you for the amazing response to the previous video. I honestly didn't expect it at all. Your support means a lot to me. If you haven't seen our previous video yet, I strongly recommend watching it first. In the previous video, we manually deployed a single web page on a public EC2 instance while covering all the key components of a VPC. In this video, we'll take it a step further by deploying an Angular application on a private EC2 instance and accessing it via a load balancer. I would say that if you're serious about learning AWS in the simplest way possible, stick with this playlist. I'll do my best to ensure you never forget it. Come on, join us. It's going to be fun and definitely worth your time. The link to the previous video is available in the description. So, without wasting any more time, let's get started. So, in the previous video, we discussed public and private subnets. We've already covered public subnets. And in this video, we'll focus solely on private subnets and exploring what they really mean. We were discussing the differences between private and public subnets. So there are two main differences. The first difference is that a public subnet has a route to the internet through an internet gateway in its route table. Additionally, instances in a public subnet typically have a public IP address. Similarly, for a private subnet, we've seen that there is no route to the internet via an internet gateway in the route table. And as discussed in the previous video, we will be replacing the internet gateway with something else to enable internet access. So today, we'll see how to enable internet access for instances in private subnets. Okay, also instances in private subnets typically do not have a public IP address assigned. As we discussed, the internet gateway forwards traffic only to instances with public IP addresses. Okay, I hope this is clear to everyone. Let's quickly go over what we covered in the previous video. In the previous video, we discussed how a user's request enters the VPC through the internet gateway, correct? Then, the internet gateway forwards the traffic to the appropriate route table for routing. Then, the route table forwards the traffic to the subnet, or instances within the specific subnet. Ignore the Bastion host for now. It's essentially just a public instance. So, don't worry, we'll cover it later in this video. When the request enters the subnet, it is checked against the NACL, right? Or we can say it's checked against the NACL rules. We've already discussed what NACL rules are, and how a smaller rule can have the highest priority. Okay, then once the request passes through the NACL, it reaches the security group attached to the EC2 instance, whether it's public or private. Then, the security group ensures that only allowed traffic is forwarded to the EC2 instances. Clear? So, we've covered this part in the previous video, right? Today, we'll discuss what private subnets are, and how to enable internet access for instances in those subnets. Okay. Next, we'll explore how to set up a Bastion host and ensure that EC2 instances in the private subnet have internet access. So, let's go ahead and create the VPC along with the necessary components inside it. Okay, now let's search for the VPC here. Okay, on the left side panel, you'll see the VPC option. Simply click on that option. We've also discussed that we'll have a default VPC. Now, let's go ahead and create the VPC by clicking the Create VPC button. Okay, alright, let's name our VPC HeisenTech Digital. Okay, then, as we know, we will be using only the IPv4 KIDR block. Here, simply provide the CIDR block. We've thoroughly discussed what CIDR blocks are and how to calculate the range within them. Okay, next, keep this option as it is, since we don't need an IPv6 CIDR block. Alright, now keep the other settings as they are and click the Create VPC button. Okay, if you look here, you'll see our VPC named HeisenTech Digital. Okay, let's select this VPC in the filter so we can view all the components related to this specific VPC. As we know, a route table is automatically created when we create a VPC. Similarly, a NACL is automatically created when the VPC is created. If you look inside the NACL table, you'll see some default inbound and outbound rules that allow traffic for our subnet inside the route table. We have the main route table, which contains the routes. As you can see, there is currently only one route, which is the CIDR block of our VPC. Today, we'll be focusing on this destination. Alright, let's go ahead and proceed further. As we know, when a user sends a request, it enters the VPC via the Internet Gateway. Okay, just like this. First, let's go ahead and create the Internet Gateway. Okay, alright. Let's name our Internet Gateway Heisentech Digital IGW. Keep the other options as they are. Click on Create Internet Gateway button. Alright, everything looks good so far. We've now created the Internet Gateway. As you can see, the Heisentech Digital Internet Gateway appears under the Internet Gateway tab. Now, we need to attach this Internet Gateway to our VPC. Let's go ahead and click on this Internet Gateway. Under the Actions dropdown, you'll see the option Attach to VPC. Click on Attach to VPC option. Here, select our VPC, Heisentech Digital VPC, and then simply click the Attach Internet Gateway button. Alright, everything looks good so far. So, here's what we've done. We've created the VPC, then created the Internet Gateway, and finally attached it to our VPC. Alright, now let's go ahead and create our subnets. For now, we'll be using the default root table and the default NACL. While we will be creating custom root tables later in this video, let's first create the subnets and instances. Then, we'll go ahead, make the necessary changes, and create the custom root tables. Let's go ahead and create the subnet first. Okay. Click on the Create Subnet button. Select our Heisentech Digital VPC, and for the subnet name, since we're creating a public subnet, I'll name it Heisentech Digital Public Subnet. Then, for the availability zone, we'll select US East 1A for the public subnet. Next, we have our VPC side. Here, we'll need to provide the CIDR for our public subnet. We've already discussed how to divide our VPC into multiple subnets and how to assign specific IP addresses to each subnet. Alright, if you're new here, I highly recommend watching the previous video so you can see how easy this all is. I'll provide the C address 10.0.0.0/28. Okay, so what does that mean? Out of the 256 available IP addresses, we are assigning 16 IP addresses to this particular subnet. And if we account for the reserved IP addresses, the available IP addresses are only 11. Alright. We've already covered all of this in the previous video. Now let's go ahead and click on the Create Subnet button. Alright, as you can see, we have created our public subnet. As we discussed, we need to make a small change for this public subnet. Let's go ahead and edit the subnet settings. Now, we need to check the Enable Auto-Assign Public IP checkbox. Okay, why do we need to select this checkbox? Because it ensures that whenever we launch an EC2 instance inside the public subnet, a public IP address will be automatically assigned to that instance. Next, go ahead and click the Save button. Alright, we're done with the creation of our public subnet. Let's go ahead and create two new private subnets. Okay. Select the Heisentech Digital VPC. Then, here, I'll provide the name Heisentech Digital Private Subnet 01. Okay. Here I'll select and create this subnet under US East 1B. Okay. Earlier we created the public subnet in US East 1A. Now, for the private subnet, we need to provide the next 16 IP addresses in the CDR block. I'll go ahead and provide the CIDR block here. I hope this is the correct one. Alright, as you can see, we are allocating the next 16 IP addresses to our private subnet. Now, let's go ahead and click on Create Subnet button. Alright. We've created one public subnet and one private subnet. As you can see, we have the public subnet and the private subnet here. Let's go ahead and create one more private subnet. Click on Create Subnet button here and select the Heisentech Digital VPC. Then, provide the name of our subnet as Heisentech Digital Private Subnet 02. Alright, now select the availability zone here. Let's select US East 1A here. For the first private EC2 instance, we selected US East 1B. Now, for the second private subnet, we will select the availability zone as US East 1A. We've already discussed how to achieve high availability by creating subnets in different availability zones, as each subnet is assigned to a specific availability zone. So let's select US East 1A here. I'll provide the CDR block for the next 16 IP addresses. As you can see, we are allocating 16 IP addresses to our second private subnet. For the first public subnet, we assigned 16 IP addresses. For the second private subnet, we also assigned 16 IP addresses. And now we are creating one more private subnet. We have assigned 16 IP addresses and now we allocating 16 IP addresses to it as well. Alright. Now let's go ahead and click on Create Subnet button. Alright, we've created 3 subnets. Okay, so the first one is the public subnet, and the second and third are private subnets. I hope this is clear so far. Okay, let's review everything we've created so far. We've created the VPC, then the Internet Gateway, and finally, we attach the Internet Gateway to the VPC. Next, we saw that we have the default route table available to us. We also have the default NACL, Network Access Control List, with us. Then, we created the public subnet. And 2 private subnets. Alright, so far so good. Okay, let's proceed further. I'll close this diagram for now and refer to a new one, okay? Now, we will refer to this diagram to create the Bastion host and the NAT Gateway. Let's go ahead and create the EC2 instances in the subnets we just created. Alright, let's search for EC2 here. Let's click on Instances in the left side panel. Okay, now we will go ahead and create 1 public instance and 2 private instances. The public instance will be in the public subnet, and the private instances will be in the private subnets. Let's click on the Launch Instance button. Okay, let's name it Heisentech Digital Public Instance. Let's go ahead and keep the other options as they are for now. Select the T2 micro instance type as it is eligible for the free tier. Now, let's select the key pair. We have already created a key pair. We'll select the existing key pair. Now let's go ahead and edit the network settings. Here, we will select our Heisentech Digital VPC. Since we are creating a public EC2 instance, we will launch this EC2 instance in the public subnet. Alright, select the public subnet located in US East 1A. Okay. We've selected the public subnet. If you notice, auto-assign public IP is enabled as we configured this setting in the subnet settings earlier. Alright. Now let's go ahead and create the security group. Let's keep this option selected. Now, let's name our security group. Heisentech Digital Security Group. Okay. We have the default SSH inbound rule in our security group. Let's leave this inbound rule as it is for now. Alright, let's go ahead and add one more inbound rule here. We will allow HTTP requests for our EC2 instance. Select HTTP and allow it from anywhere. The port used for HTTP is 80. Alright, this part is done. Let's go ahead and click on the Launch Instance button. Okay, we've just created our first public EC2 instance. We can say that we have successfully launched our public EC2 instance in the public subnet. Now, let's go ahead and launch 2 new private EC2 instances inside our private subnets. Now, click on the Launch Instance button again. Let's name it Heisentech Digital Private Instance. Alright, now let's scroll down and keep the other options as they are. Since we have the key pair, let's proceed. Let's select the My Test key pair. Now, let's go ahead and edit the network settings. Okay, now select our Heisentech Digital VPC. Now, we will launch this EC2 instance in private subnet zone 1, which is located in availability zone US East 1B. Okay, as you can see, the auto-assign public IP option is disabled for the private subnet. So what does this mean? It means that the EC2 instance we're launching inside the private subnet will not have a public IP address. For the security group, let's select the existing one that we just created. Let's select the Hygienic Digital Security group. Okay, next, keep all other settings as they are. And let's click on Launch Instance. Okay, now, we have successfully created 2 EC2 instances, one public and one private. If you look closely, we have created one instance in US East 1B and the other in US East 1A. Now, we need to create one more private EC2 instance inside US East 1A. Alright, let's go ahead and click on Launch Instance again. I will name it Heisentech Digital Private Instance 02. Okay, keep the other options as they are. Select the key pair we have, which is my test key pair. Now, let's edit the network settings and select our VPC, which is Heisentech Digital VPC. For the subnet, we will now launch this EC2 instance inside the US East 1A availability zone, which corresponds to our private subnet 02. Okay, as you can see, the auto-assign public IP option is disabled for this instance as well. Now, we will select our existing security group, Tech Digital Security Group. Okay, now let's go ahead and click the Launch Instance button. You'll see that we have created 3 EC2 instances, 1 public ECU instance, and 2 private EC2 instances. Let's rename this instance as Private Instance 01 for better understanding. So, this is our public instance. And these are our private instances. Okay, everything is going smoothly so far. So referring to the diagram, here's what we've created so far. We have created the VPC, set up the Internet Gateway, and attached it to the VPC. Then, along with the VPC creation, the main route table is automatically created. Next, we created the public subnet and 2 private subnets within the VPC. Then we launched EC2 instances in both the public and private subnets. Now, let's proceed and attempt to SSH into our EC2 instance. Since we have created a public instance, we can only access it directly because it has a public IP address assigned. Here, only the public instance will be accessible via SSH due to this public IP. As we know, public subnets contain resources that can directly access the internet. These resources are typically assigned public IP addresses, allowing them to communicate with external networks without any additional configurations. Let's go ahead and attempt to SSH into the EC2 instance in the public subnet. As you can see, our private instances do not have public IP addresses assigned to them. Since these private instances do not have public IP addresses, they do not have direct internet access. Alright, let's move forward and explore step by step how we can provide internet access to these private instances using their private IP addresses. Let's try to SSH into the public EC2 instance now. So command is SSHE. Use my test key pair which is saved on my desktop. Here, I will use the public IP address, which is 18.212.67.242. Okay, as you can see, we are unable to SSH into our EC2 instance. Alright, take a moment to pause the video and think about why we're unable to SSH into our public EC2 instance. Now, let's take a look at why we're unable to SSH into the instance. Let's refer to this diagram for clarification. Okay, so we've created the Internet Gateway and attached it to our VPC. Along with the creation of the VPC, the main route table is automatically created. However, if you notice, we haven't added a route for the Internet Gateway in our route table. Let's check the main route table to verify its configuration. If you see, we have only one entry, which is the local entry. This local entry is automatically created when we create the VPC along with the main route table. Okay, also when we create a custom route table, this entry is automatically included by default, and we cannot edit or remove it. So what does this entry actually do? This entry represents our VPC header, which allows communication between all the resources within the VPC. Let's focus on this line. This entry allows communication between all the resources within the VPC. Let me say it again for clarity. We can say that this entry enables communication between all the resources within the VPC. This entry allows communication between EC2 instances across different subnets within the VPC. Let's say we have created 1 public subnet and 2 private subnets. This entry ensures that communication is allowed between our EC2 instances across the different subnets within the VPC. Got it. Clear now. Keep in mind what this entry actually does. Now, as we know, each subnet in a VPC is associated with a route table that determines how network traffic is routed, both within and outside the VPC. Let's go ahead and create a custom route table and associate it with specific subnets. Now, click on the Create Route Table button. Okay, let's name our route table Tech Digital Public Route Table. Okay, now we need to select our VPC. Now let's go ahead and select our Tech Digital VPC. And that's all for now. So, let's go ahead and click on the Create Route Table button. Great, everything looks perfect. As you can see, we've just created our public route table. Under the Route tab, you'll notice we have the local entry listed. I'll repeat this once again. This entry enables communication between all resources within the VPC. Now let's move ahead and create the private route table. Now click on the Create Route Table button. Let's name it Tech Digital Private Route Table. Okay, next here, we will select the VPC as Tech Digital VPC and then click on Create Route Table button. Okay, alright, we have successfully created 2 route tables. One is public route table and the other private route table. Now, as we know, we need to add one more route to the public route table, which will be the Internet Gateway route. Since our VPC is connected to the Internet via the Internet Gateway, this route will allow outbound traffic to flow from the VPC to the Internet. Now let's proceed to add one more entry here. Now let's click on Edit Routes button. Let's click on the Add Route button. Now select this entry. I have already explained. This represents the entire range of IPv4 addresses. From the 4.3 billion can route through this route table and access the Internet. Here, let's select the Internet Gateway. If you look here, you'll see the Heisentech Digital Internet Gateway. Okay, let's click on this. Click on the Save Changes button. This Internet Gateway route is what enables Internet connectivity. So we can say that the route table controls the Internet connectivity for our subnet. So this entry ensures that instances within the public subnet have Internet access by routing traffic through the Internet Gateway. And this entry allows communication between EC2 instances that are in different subnets within the VPC. Okay, everything is going smoothly so far. Let's take a look at our private route table. As you can see under the Routes tab, there is only the local entry listed. So, in the private route table, we will not add an Internet Gateway route, because the Internet Gateway is only responsible for forwarding traffic to instances that have a public IP address associated with them. Even if we add an Internet Gateway route in the private route table, the private instances will still not be able to access the Internet, as we discussed in the previous video. And the Internet Gateway only works for instances with public IPs. Private instances do not have public IP addresses. So let's leave this entry as it is for now. So now let's proceed by referring to our diagram. We have created the VPC, set up the Internet Gateway, and attached it to the VPC. Then we created a custom route table and added the Internet Gateway route to the public route table. Is that clear now? When a user sends a request, it first reaches the Internet Gateway. From there, the request is directed to the public route table, which contains the route for the Internet. The traffic then passes through the Network Access Control List, NACL, and Security Group. Finally, it reaches the desired EC2 instance in the public subnet. So, we can say now we are done with our setup and have successfully configured everything needed for both public subnet, including routing, security, and connectivity for our EC2. Additionally, as we have seen, we have the proper entries in the Network Access Control List table. We've added the necessary SSH and HTTP rules in our security group to allow communication to our EC2 instances. Let's go ahead and try to SSH into the public EC2 instance now. Alright, let's go ahead and enter the command again. It's still not working. Okay, so we missed one step. We created the route table, but we haven't associated it with a specific subnet. In our case, the public subnet. Let's go ahead and associate the public route table with our public subnet. So here under Subnet Associations, you will see the option to click on Edit Subnet Associations. Click on the Edit Subnet Associations button. Here select our public subnet, as we are associating the public route table with the public subnet. Click on the Subnet Associations button. Okay. Additionally, let us go ahead and associate the private route table with our private subnets. Now let's click on the Subnet Associations tab. Next, click on the Edit Subnet Associations button. Then, select our private subnets. We are using a single custom route table for our two private subnets. Does that sound good? Now, let's click on Save Associations to finalize the changes. So, we have successfully completed the route table association process. Now, let's proceed and check our SSH connection. Looks like it's working now. Now, as you can see, we are successfully inside our EC2 instance. Yes, it's clear. So, if you look at this private IP address, which is 10.0.0.14, it's the private IP address of our EC2 instance within the public subnet. This IP is used for internal communication within the VPC, and it won't be directly accessible from the internet. Okay, understood? Now, let's go ahead and try to understand what a Bastion host is. So what is a Bastion host? So I would say a Bastion host is a public instance that serves as a secure gateway, allowing access to private resources or private instances within a network. In simple terms, you can say a Bastion host is a public instance that allows secure access to private instances. Okay, it's very easy to understand since we already know about public instances. The only difference is that the Bastion host has limited ports open, specifically port 22 for SSH and port 3389 for RDP. As we mentioned, The Bastion host is a public instance, so it must be located in the public subnet. Everything so far is clear. If we refer to our diagram, you can see the Bastion host users. These users are trying to access our EC2 instances, and the Bastion host is placed in the public subnet, serving as the gateway for secure access. Since we've already added the Internet Gateway root table entries, along with the necessary NACL and security group configurations, so we are successfully able to SSH into the public instance, which is nothing but the Bastion host instance. This public instance itself is our Bastion host, and we also refer to it as a jump host. So what is the purpose of a Bastion host? You might wonder, since this is just a public instance, what is its purpose? We've already created public instances in the previous video, so why are we specifically referring to this one as a Bastion host now? Now let's take a look at our root table. If we examine the public root table, you'll notice it contains two routes. One for the Internet Gateway, allowing outbound traffic to the internet, and the other for internal communication, which is the local entry. As I mentioned earlier, this entry ensures the internal communication between EC2 instances placed in different subnets within the VPC. We can say that this entry facilitates communication between all resources within the VPC. We can say that this entry enables communication between EC2 instances. So ideally, we can rename our public instance to Bastion host instance. So now, as I mentioned, this root table entry allows communication between different resources in our VPC. Now we have logged into the Bastion host instance. As you can see, we are currently on the Bastion host instance. So, does this mean we are now inside the VPC? Since the user is able to SSH into the EC2 instance, and the instance is inside the VPC, it means the user is already within the VPC, correct? So, this root table has the local entry, which allows communication between resources placed in different subnets within the VPC. This means we can connect to or SSH into our private instances, correct? Now, let's see how we can access the instance placed inside the private subnet from the Bastion host instance. What we will do is SSH from the Bastion host instance to our private instance. I hope this is clear, right? In simple terms, inside the root table, this is our CIDR block, which in our case includes all 256 IP addresses. We've divided these 256 IP addresses into 3 different subnets. So the IP address of this EC2 instance is one of the addresses from this CIDR block. This means the instance can connect with the private instance using its private IP address. Once the user is inside the VPC, this entry allows communication between instances using private IP addresses. Got it, clear now. Let's go ahead and try to SSH into the private instance from the Bastion host instance. To SSH into the private instance, there are a few key things we'll need. First, as we know, AWS requires the use of a key pair for securely accessing EC2 instances. The first thing we need is the key pair. As we know, the public key is stored on the EC2 instance. The private key from the key pair is essential for authentication when establishing an SSH connection, and we use the private key to securely connect via SSH. We just demonstrated this process earlier. We just SSH'd from my local machine to our public instance using this key pair, right? Clear. I will attempt to SSH into the public instance once again. Okay, now that we're on the public instance, we can say we're effectively on the Bastion host instance. Okay, so to SSH from this Bastion host public instance to our private instance, we need to establish a connection from the public instance to the private instance. If we look at the private instance, we can see that we are using the key pair named myTestKeyPair for SSH access. For now, in our case, we are using the same key pair for both the public and private instances. We can use different key pairs for your public and private instances if needed. Okay, so I have this key pair stored on my machine, right? So, in order to SSH from this public instance to the private instance, I would need the key pair on the public instance, correct? Only then will I be able to SSH from the public instance to the private instance. Okay. Let's move ahead and see how we can transfer the key pair to our Bastion host instance. Okay, there are several ways to transfer the key pair to the Bastion host instance. But for now, we'll follow the simplest method. One of the methods is to SCP the key pair from my local machine to the Bastion host instance. Alternatively, we can use an S3 bucket to copy the key pair from S3 to this EC2 instance. No worries, we'll follow the simplest method here. So I will create and open a file, naming it key.pem. Okay, I have that key pair saved on my desktop. I will open it using Visual Studio Code. So, I have this key on my local machine, specifically on the desktop. What I will do is simply copy it and paste it onto our Bastion Host instance. So now, we have successfully transferred the key to our Bastion Host instance. As we discussed earlier, to SSH from this public instance or Bastion Host instance to the private instance, we will need the key pair. As we know, to securely access an EC2 instance, AWS requires the use of a key pair. This is clear, and we are already familiar with it, right? So, let's go ahead and try to SSH into our private instance from this Bastion Host instance. We'll use the following SSH command: ik.pemec2 user a private IP of private instance. Next, let's copy the private IP address of our private instance. We know that the local entry in our root table, which is assigned to the public subnet. And this entry allows communication between different resources or instances located in different subnets. Keep in mind that once you're inside the VPC, you can communicate with all the resources within your VPC or across different subnets using their private IP addresses, thanks to this entry. Or you can say, once inside the VPC, you can freely communicate across different resources using their private IP addresses. So I will paste the private IP address here and attempt to SSH into the instance. Yeah, now if you look at this private IP address, see, this is the private IP address of our private instance, 10.0.0.29. Earlier, the private IP address was 10.0.0.14. Now, the private IP address is 10.0.0.29. This means we are successfully able to SSH into our private EC2 instance. So, a Bastion host is essentially our public instance, used to securely SSH into private instances, with only limited ports open. Those ports are 22 for SSH and 3389 for RDP, which is typically used for remote desktop access. So I hope this is clear now. So, now we are logged into our private EC2 instance, right? As I mentioned earlier, even though we are logged into our private EC2 instance, we do not have internet access on this private instance. As you can see, if we check the root table for the private subnet, we can see that there's only one entry, the local entry. And we already know the purpose of this local entry. It only allows communication between the resources within the VPC. As you can see, we don't have an internet gateway entry here. So this means our private instance does not have internet access. So if I check by typing the command ping www.google.com, you'll notice that we don't have internet access for this particular private EC2 instance. For example, let's say we need to install Apache on our private instance. Let's try running that command. See, it's not able to install Apache because we do not have internet access on this EC2 instance. As we have only one entry in the root table, which is associated with our private subnets, which is the local entry, this instance cannot access the internet. Everything is going smoothly so far. Now, this is where the NAT Gateway comes into play. As discussed in the previous video, instead of adding an internet gateway here, we need to add a NAT Gateway entry in this root table. Why? Because the internet gateway only forwards traffic to instances that have a public IP address associated with them. So, even if we add the internet gateway entry to the private root table, we still won't be able to access the internet on the private EC2 instance. Correct? So now, if I am saying that we need to add a NAT gateway entry in this private root table, what exactly is a NAT gateway? So, a NAT gateway is essentially a network address translation service. So a NAT gateway lets instances in a private subnet access the internet for tasks like downloading software updates, accessing APIs, etc., without being directly exposed. It only allows outbound traffic from private instances to the internet. It do not accept incoming traffic from the internet to those private instances. Since our private instance doesn't have a public IP address, the NAT gateway allows instances in the private subnet to access the internet without being directly exposed. Since the private EC2 instance doesn't have a public IP address, if it needs to access the internet, it sends the traffic to the NAT gateway. So, how does the NAT gateway work? The NAT gateway handles the translation of the private IP address to a public IP address by replacing the private IP with its own public elastic IP. Okay, let's refer to our diagram now. As I mentioned, the NAT Gateway handles the translation of private IP addresses to public IP addresses. It simply replaces the private IP address of the EC2 instance with its own public elastic IP address. If we create a NAT gateway and add its entry to our private root table, then the request to the Internet Gateway will appear to come from the NAT Gateway's public IP address instead of the private instance's IP address. The private instance will never be able to access the Internet directly through the Internet Gateway. This is because the Internet Gateway only forwards traffic to instances that have a public IP address associated with them. Since the private EC2 instance does not have a public IP address, it cannot communicate with the Internet directly through the gateway. In the case of a NAT gateway, we create a NAT gateway and add it to the root table. And when the EC2 instance in the private subnet needs Internet access, it sends a request to the NAT gateway via the root table. Since we have the NAT gateway entry in the root table, the request is forwarded to the NAT gateway. The NAT gateway then replaces the private IP address of the EC2 instance with its own public elastic IP address, and with that public IP address, the NAT gateway will forward the request to the Internet Gateway, allowing the private instance to access the Internet. And if the resource has a public IP address, the Internet Gateway will grant Internet access to that resource, as we already know. Clear? Now, what we need to do is go ahead and create the NAT Gateway, then add the NAT Gateway root to our root table. Once we add the NAT Gateway entry in our root table, we can then say that our private instance will have Internet access. So, to provide Internet access to the private EC2 instance, the request will first go to the root table. Once we add the NAT Gateway entry to the root table will redirect the request from the EC2 instance to the NAT Gateway. The NAT Gateway will then replace the private IP address of the requesting EC2 instance with its own public elastic IP address. Finally, it will forward the request to the Internet Gateway, which will provide Internet access. Let's go ahead and implement these practically. So let's proceed. As you can see, we still don't have Internet access, and it's still loading. I'll go ahead and close it now. Okay, now let's go ahead and create the NAT Gateway. Okay, click on NAT Gateway in the left-hand panel. Then select the Create NAT Gateway button. Let's name it Heisentech Digital NAT Gateway for clarity. Okay, and for the subnet, if you refer to this diagram, if you see, you'll notice that the NAT Gateway must be placed in the public subnet. Okay, so let us go ahead and place it in our public subnet. Next, the connection type should be set to public. Then here, as I mentioned earlier, when a request comes to the NAT Gateway from any EC2 instance, the NAT Gateway will replace the EC2 instance's private IP with its own elastic public IP. If you look here, we have the option to allocate an elastic IP. This means we are assigning a static public IP address to the NAT Gateway. Got it, clear. So what does that mean? Whenever a request is sent to the NAT Gateway, it will simply replace the private IP address with its own static public IP address, and it will forward the request to the Internet Gateway. Next, I will click on Allocate IP Address button. As you can see, we have one IP address allocated to this NAT Gateway. Make sure to delete the NAT Gateway and elastic IP once you're done with your practice, as AWS will charge you for using them. Now, let's go ahead and click on the Create NAT Gateway button. Alright, we have completed the NAT Gateway creation process. Next, we need to add the entry for this NAT Gateway in our private root table. As you can see, I have selected the private root table here. As you can see under the Roots section, we currently only have the local entry. Now, let's go ahead and add the NAT Gateway entry here. Now let's click on the Edit Roots button, and then click on the Add Root button. Here, select the CIDR block, which represents the entire range of 4.3 billion IP addresses. Now, select the NAT Gateway option. If you look here, you can see our Heisentech Digital NAT Gateway entry. Now click on Save Changes. So if you look here now, inside our private route table, Heisentech Digital Private Root Table, we have two entries. One is the default local entry, and the second is the entry for the NAT Gateway. So, inside our private root table, we do not have an Internet Gateway root entry. Instead, we have this NAT Gateway root entry. And the purpose of the NAT Gateway is replace the private IP address of the EC2 instance with the NAT Gateway's elastic public IP address. It then forwards the request to the Internet Gateway, allowing the private EC2 instance to access the Internet. Okay, everything's going well so far. Now, Let's go ahead and check. Are we able to install Apache and verify if our private instance has internet access? So I will try pinging www.google.com again to check the internet connectivity. See, now we have the internet access on our private EC2 instance, and now we can access the internet from our private EC2 instance. I hope this explanation is clear, since we are using the same root table for both private EC2 instances. Both of our private instances now have internet access. Clear? So the next thing we'll do is, since I've already logged into this private EC2 instance, let's proceed with the next steps. Next, we'll go ahead and install Apache on this private EC2 instance, and then we'll deploy an Angular application on it. Let's go ahead and install Apache on this private EC2 instance. In the previous video, we saw that we weren't able to access the internet on our private instance. However, now that we've added a NAT gateway to our private root table, we can access the internet on this private instance. So, let's go ahead and update all the packages first. No worries about the commands. I will provide all the necessary commands in the description. You can simply copy and paste the commands from the description and follow along with the steps I'm demonstrating here. The next step is to install Apache. I am running one command at a time for your convenience and better understanding. As you can see, we have successfully installed Apache. Now, let's go ahead and start the Apache service. Since we're going to deploy an Angular application, I have created an Angular application repository. I created it a while ago, so the Angular version might be older, but no worries. We'll give it a try and see how it goes. To do that, we will need to install Git on our EC2 instance. Let's go ahead and quickly install Git on this instance. Alright, we have successfully installed Git on this instance. As you can see, I have created this Angular project repository, which is a public repository. I will also provide the repository link in the description for your reference. Let's go ahead and copy the clone with https URL. Now, let's run the command git clone URL to clone the repository. As you can see, we now have the Angular repository successfully cloned from GitLab. So, in order to deploy the Angular application, we'll need to install nodejs on this EC2 instance. We can install nodejs on our instance or server using this command. Okay, we will also need the Angular CLI. I will go ahead and install the Angular CLI as well. For now, don't worry about the Angular CLI or the Angular project itself, as we are doing the deployment manually. Just follow the commands here. When we begin working on the actual CI/CD pipeline, I will explain the entire project structure, whether it's an Angular project, a Java Spring Boot application, or any other project we deploy. I will ensure that by the end of it, you will be comfortable with the project structure, its components, and its architecture. This will help you become more familiar with deploying applications in your future projects, making you confident in understanding and managing the deployment process within your organization. What I mean is, I will guide you through all the essential tools and technologies at a basic level, along with AWS and DevOps concepts. This way, you'll have a solid foundation to work with these tools and effectively deploy and manage applications, while also building your understanding of the underlying processes and workflows in DevOps environments. Sounds good. As you can see, we're currently facing a permission issue. Let's go ahead and use the sudo command to resolve this for now. So, we are installing the Angular CLI on our private instance with sudo permissions. I think there were some issues regarding the NPM version, but for now, you can ignore it, as it's just a warning and not an error. Despite that, we were still able to successfully install the Angular CLI on our private instance. So, we have successfully installed Git, Apache, and Angular CLI. Now, let's navigate to our Angular repository. If you take a look, you'll see the files and folders inside this Angular project. Don't worry. In a future video, I'll quickly explain how Angular works and go over the folder and file structure inside an Angular project. Whether it's Spring Boot, Python, Node.js, I'll explain the structure and key components of those projects, or any other technology. Now, we will go ahead and build this application as we need to deploy it. Before building the project, we need to install the required dependencies. Let's go ahead and Install the required packages using the npm install command. It will take some time to install the dependencies. Don't worry. Even though we're doing this manual deployment, it's important for you to understand. In the future, if you need to automate this process, you'll still use the same commands. The only difference is that you won't run them manually. Instead, automation will handle it for you. Being familiar with this manual deployment process will make it much easier for you to understand automation and CI/CD pipelines down the line. Now that we have installed the necessary packages, let's go ahead and build our Angular project. I will enter no. Now, as you can see, this command is building the Angular project. Before deployment, we need to build our project. Don't worry, I will explain everything in future videos. For now, just follow the steps I'm demonstrating, and I will provide all the commands in the description of this video. Okay, this will take some time. The build process is still running. Meanwhile, I'm logging into another EC2 instance, a private EC2 instance, in a different tab, where I am installing the same setup. We can save a little bit of time this way. Yes. We have completed the build process for the Angular project. So meanwhile, on the second instance, I have also installed the Angular application. Installed the Angular application and its dependencies. Now I will go ahead and build the Angular project on the second private instance as well. Now, as you can see, we have completed the build process of the Angular project on this private instance. If you look here, we have this dist directory, right? So, inside the dist directory, if you go into the my app folder, this is the application name. The dist folder will contain a directory named after your app. Inside this directory, you'll find all the compiled and optimized files ready for deployment. Don't worry, I'll explain in the future what these files are and how to deploy an Angular application. For now, just keep in mind that we need to copy all the files from this my app directory to the var www.html directory, which is the default directory for serving web files with Apache. If you look inside the my app directory, you'll see the index.html file. In the previous video, we deployed a simple web page by placing a single index.html file inside the default directory of Apache. The only difference here is that, along with the index.html, we also have a few additional JavaScript and CSS static files. So what I will do is copy all the files from the dist/myapp directory to the var www.html location. So here you will be able to see all the files from our dist/myapp directory inside the var www.html location. So ideally, we can say that the deployment is complete. I would say this is the manual deployment of an Angular application on a private EC2 instance. Okay, I will exit from this instance now. So here on the second private instance, let's go ahead and build the application. It will take some time, so let's wait for about 2 more minutes. We are done with the build process of the Angular application. If you see here, we also have this dist directory. So what I will do is copy everything from the dist directory to the var www.html location. Okay, so ideally, we are done with the manual deployment of the Angular application on the second private EC2 instance as well. So now, let's review what we have covered so far. Earlier, in previous video, we have already covered topics such as NAT Gateway, root table, NACL and security groups. Today, we explored the concepts of Bastion Host and NAT Gateway. The Bastion Host is essentially a public EC2 instance, also known as a jump host, which allows us to securely SSH into private EC2 instances located in private subnets. We are able to SSH into the private instance from the public instance because of the local entry in our root table. This entry allows communication between resources within the same VPC, ensuring that the public instance can reach the private instance securely. Everything seems clear so far. Then, we created the NAT Gateway and added its root to our private root table, which is associated with the private subnet. Whenever a private EC2 instance makes a request to access the internet, the request first goes to the root table. Since we've added the NAT Gateway entry in the root table, it forwards the request to the NAT Gateway. The NAT Gateway then replaces the private IP address of the EC2 instance with its own public elastic IP address and forwards the request to the Internet Gateway. So now, the request appears to come from the NAT Gateway's public IP address. rather than the private IP address of the EC2 instance. Is that clear? Okay. So now what's the next step? We've deployed the Angular application on both of these private EC2 instances, and we also have our Bastion host in the public subnet, which is essentially our public instance. Let's proceed and create a load balancer to access the application deployed on our private EC2 instances. I'll go ahead and quickly set up a load balancer. Guys, we have a dedicated video on load balancers, and I highly recommend you watch it. Alright, now I'll click on the Create Load Balancer button. Next, I will go ahead and create an application load balancer here. I will name it Heisentech Digital ALB. Okay, the scheme should be set to internet facing, and the load balancer IP address type should be IPv4. Next, under the network mapping section, we need to select our VPC. Now let's select our Heisentech Digital VPC here. Next, we need to select two availability zones. Due to time constraints, we're using one public subnet where the Bastion host is for the load balancer. Since we're using the same security group for all resources, for the second availability zone, this works fine. We'll choose a private subnet as scalability. And traffic aren't concerns for now. However, I recommend you create two additional public subnets for better high availability and redundancy. So now, is everything clear now? Let's select the security group and set the listener port to 80. After that, we need to create a target group. Let's go ahead and create the target group. The target type should be set to instances, as we are selecting the private EC2 instances as the targets for the load balancer. Let's name this target group as Heisentech Digital Target Group. Here, we will be using the default port 80 for the target group. Here select our VPC, which is Heisentech Digital. Select the protocol version as HTTP1. Keep the health check settings as default. Click on the next button. So now, we want to access our Angular application that is deployed on the private instances through the load balancer. So, we will add these private EC2 instances as targets under the target group. I highly recommend you watch the dedicated video on load balancers for a more detailed explanation. Click on the Include as Pending button below. Now, click on the Create Target Group button. Alright, we have successfully created the target group. As you can see, the health status is currently marked as unused. Let's go ahead and forward the traffic to this target group through the load balancer. Let me reload here. Okay, let's select the Heisentech Digital Target Group that we just created. And let's click on the Create Load Balancer button. Okay, so we are done with the load balancer creation. We have successfully created the target group and added the two targets where we deployed our Angular application. Everything seems to be going smoothly so far. As you can see, it's showing 0 healthy targets. As you can see, the health status for both targets is still in the initial state. Let's wait for a couple of minutes. As you can see now, it's showing 2 healthy instances. Now, as you can see, the health status is healthy for both targets. Now let's go ahead and copy this DNS name and try to access our Angular application, which we have deployed on the private EC2 instances. Okay, it's loading now. As you can see, awesome. We've successfully accessed the Angular application that we deployed on our EC2 instances. Mission accomplished. I hope this is clear to everyone. Let's go ahead and quickly revise everything we've created and covered today so far. Set up an internet gateway and attached it to the VPC. When a user sends a request, the internet gateway forwards it to the root table, which then directs the traffic to the public subnet, where our public instances are. One of these instances is acting as a Bastion host. I hope the concept of the Bastion host is clear to everyone. A Bastion host is a secure instance that lets you access private instances in a VPC, especially when those private instances don't have direct internet access. Today, we've also explored the NAT Gateway. We've seen how to enable internet access for private instances within a private subnet using the NAT Gateway. NAT gateways only allow outbound traffic from private instances to the internet. We created a NAT gateway. They do not accept incoming traffic from the internet to those private instances, and added its root entry into the root table. This allows private instances to access the internet through the NAT gateway. When the EC2 instance in the private subnet needs internet access, it sends the request to the root table. The root table then forwards the request to the NAT gateway. The NAT gateway will then translate the private IP of the EC2 instance to its own public IP and forward the request to the internet gateway for internet access. And then The Internet Gateway sends the internet response back to the NAT Gateway, which then forwards it to the Private EC2 instance. I hope this is clear to everyone. That's all for today. In the next video, we'll dive into exploring the IAM service. Stay tuned. Don't forget to like, subscribe, and hit the notification bell so you never miss an update. Drop any questions in the comments below, and I'll be happy to help. Thanks for watching. See you in the next video. Take care. Thank you.